HDR Insight Series 3, Understanding HDR Tone Mapping. In the previous series, High Dynamic Range Transfer Functions, we discussed the transfer functions and how digital images are converted to light levels for display. This article discusses how the same high dynamic range image can be displayed differently by different high dynamic range devices. What is high dynamic range tone mapping? Tone mapping is the process of adapting digital signals to appropriate light levels based on the high dynamic range metadata. This process is not simply applying the EOTF electro-optical transfer function on the image data, but it is rather trying to map the image data with the display device capabilities using metadata information. Since a broad range of high dynamic range display devices are available in the market, each with their own nits, that is brightness range, correct tone mapping is necessary for a good user experience. Since the tone mapping is done based on the metadata in the video stream, presence of correct metadata is necessary. Source footage can be shot at high dynamic range with best of cameras and then mastered on high-end high dynamic range mastering systems, but it still need to be displayed optimally on the range of high dynamic range televisions available in the market. Tone mapping performs an appropriate brightness mapping of the content to device without significant degradation. Need for high dynamic range tone mapping. On a television with a 0 to 2000 nits range, the brightness range will be exactly as shot in the raw footage. However, the results will be different on other devices, since tone mapping is a necessary operation to display perceptual quantizer-based high dynamic range content on high dynamic range display devices. The television needs to know the native properties of the content in terms of the brightness range used along with mastering system parameters. This information is conveyed in the form of high dynamic range metadata. After reading the high dynamic range metadata, display devices can decide the tone mapping parameters so that the transformed video lies optimally within the display range of the display device. Definitions. Candela per square meter. The candela CD is the base unit of luminous intensity in the International System of Units SI, that is, luminous power per unit solid angle emitted by a point light source in a particular direction. A common wax candle emits light with a luminous intensity of roughly 1 candela. Nits, a non-SI unit used to describe the luminance. 1 nit is equal to 1 candela per square meter. HDR, High Dynamic Range. It is a technology that improves the brightness and contrast range in an image up to 10,000 candela per square meter. SDR, Standard Dynamic Range. It refers to the brightness contrast range that is usually available in regular, non-high dynamic range televisions, usually with range of up to 100 candela per square meter. This term came into existence after high dynamic range was introduced. WCG, Wide Color Gamut. Color gamut that offer a wider range of colors than BT.709. DCI-P3 and BT.2020 are examples of wide color gamut offering more realistic representation of images on display devices. EOTF, Electro-Optical Transfer Function. A mathematical transfer function that describes how digital values will be converted to light on a display device. OETF, Optical Electro Transfer Function. A mathematical transfer function that describes how the light values will be converted to digital values, typically within cameras. OOTF, Opto-Optical Transfer Function. This transfer function compensates for the difference in tonal perception between the environment of the camera and that of the display. PQ, Perceptual Quantizer, is a transfer function devised to represent the wide brightness range up to 10,000 nits in high dynamic range devices. HLG, Hybrid Log Gamma, is a transfer function devised to represent the wide brightness range in high dynamic range devices. Hybrid log gamma is quite compatible with existing static dynamic range devices in the static dynamic range. Thank you for listening to our podcast. For more details, visit our website to find extra resources.